Hello, I'm Paul White, and today I'm talking with Nate Baglyos and Charles Sprinkles of Carly Audio about their approach to designing monitor loudspeakers. Nate is Director of Marketing and Charles is the Head of Acoustics. Nate, why studio monitors? It's a very crowded market, isn't it?
We all met working at a larger company and knew that we liked each other and knew that we worked well with each other. And knew that we wanted to do something in terms of a loudspeaker company. And so the question was, what do we do first? Do we do a PA speaker? Do we do cinema speakers or installed speakers? And looking at the sort of general overview of all the different things that we could start with, studio monitors made sense as something that isn't terribly expensive, that would be its own marketing push, because they are sort of a semi-consumer good, and help us get our name out there so that as we look to expand into further markets, we've got something that people know what we're capable of. And it was also something, studio monitors are really fun. It allows us to be in the studio world, which means that we're working directly with musicians and engineers and producers. It's a fun thing to make, and it's a fun thing to see when our customers come back and say, hey, I really love your product. I really love what you make. It's really helped me do this. Here's what I made. That's great. And you don't get that with an installed speaker. Here's how the principal sounded doing the morning announcements is not the same as here's the record I just produced.
Yeah, that's true, Nate. So when you're developing a speaker like this, how do you go about it? Because you've either got the choice of buying off-the-shelf drivers and then working within their limitations, or you've got to develop your own drivers and have them made, which means expense and time. Which route did you take, Charles?
So a couple of things to go back to your last question as far as starting. One of the other reasons that we started in the categories we were in is because we had extensive experience in this category. This is what we did for a living. So to your question, as far as whether we're buying off-the-shelf transducers or we're designing our own, of course, this is something where we can add value by designing our own transducers. It takes a little bit more development expense. It takes more time to do. But the value add is significant because we can tailor the requirements of the transducer to the entire system integration and to make sure that we're getting the full performance of the driver at the same time as we're getting the full performance of the amplifier, which makes the best value proposition for our customer.
Certainly, Charles, for the speakers that you've designed so far, paradigm seems to be somewhat different from monitors that I've tried from the company for which you previously worked. So what is your philosophy? I mean, some people go for it's got to be metal tweeters, other people it's got to be soft dome tweeters, and then the metal guys say, but the soft dome ones distort and you get breakup modes, and then the soft tweeter guys say, yeah, but the metal ones resonate and they sound hard. And which of the many inevitable compromises do you feel is the least worst?
I don't want to box myself into a corner as far as any particular technology. Each technology, if you're talking about diaphragm materials for tweeters, as an example, all of them have their own advantages, and they all have their own drawbacks. And the real question is, how do you adjust that, or how do you choose that based on the product that you're developing? So for our entry-level line, we're using soft dome tweeters because at that price point, can perform very well for what they are. Now, moving up in price point, different choices could be made, but the drawbacks also have to be addressed such that you don't get the big objections. As an example, metal dome tweeters, yeah, they're known for having a big resonance above 20 kilohertz, but those through careful geometry and optimization might be able to be mitigated.
And then we move down to the mid-range diaphragm materials there. I mean, paper has good self-damping. Other people prefer some kind of synthetic. Which way do you lean on that?
I am an unashamed paper enthusiast. It's very stiff. It has good self-damping characteristics. To me, the drawback of paper is that it might not be perceived as exotic, but it is wonderful stuff. If you look at some of the high-end products that were created by a company that I used to work for, specific to iconic products for the high-end market using paper cone woofers. This is where he got a full dose of the benefits of a well-chosen paper pulp, even though it doesn't look exotic. The way that directivity transitions can be controlled through appropriate modification of the shape of the diaphragm, all of those little details gives you a lot of value for the money that you spend.
That seems to tie in with what I've heard from some high-end British manufacturers who also really like to use paper because of its properties. And if you tap the cone of some of these synthetic ones, you can hear what the speakers are going to sound like before you even plug it in.
Yeah, well, we call that cone cry. And it's really pronounced on some, as an example, metal cone. And it's one of those things that if you were to use it, you would have to deal with that characteristic.
Of course, there's more to a loudspeaker than just drivers. If it's a passive speaker, you've got to put crossovers in there. These days, we have a lot of DSP looking after crossovers and switch mode amplifiers. There's a lot of R&D there.
Yes, there certainly is. And I think if you look at the products that we have out, that we started with, even going back to products that we did in a different life, you can see a clear progression of lessons learned. You know, as an example, switch mode amplifiers have their own opportunities for improvement, shall we say. And as the technology has increased and you have improvements in dynamic range, improvements in bringing the distortion level down, you'll see that we've realized at every step that we can those improvements.
When it comes to the DSP side of things, I mean, do you think in the early days people were relying too much on DSP to try and iron out the problems inherent in their designs?
Mm-hmm. Well, it is tempting. And to avoid using an analogy, how do I want to say this? It is best to fully optimize your transducers first for all the characteristics that they have to have first for directivity. Get the waveguide, or get the directivity right of the system, and then you're not going to have to use so much DSP or EQ to fix problems, because in general, when you start just trying to fix things with EQ, well, it's still there, right? The actual problem is still there. I mean, you're just putting some makeup on it, you're smoothing it over. You need to address the problems. Going back to, this is the reason why we design our own drivers. This is why we do it. You've got to have a strong foundation to build a strong system.
And again, yeah, talking to some of the British designers, they've said much the same thing. You've got to get the basic components right, and then maybe use the DSP for fine-tuning rather than trying to beat it into shape with the DSP, which never works.
Well, you know, in the industry, there exists predictive models for, as an example, nonlinear distortion. And DSP solutions to make those inexpensive drivers sound like more than they are. I'm not saying it can't work. I'm saying that in general, it's not a good idea when what your goal is. In our market, our goal isn't to make a nice sounding loudspeaker that people are going to put in their living rooms. That's fine. But what we create, what we build is tools used by professionals to create music. And this is the reason why we need to do it right. We need to start with a strong foundation. At every price point, we need to build a product that has that design thought into it.
And of course, things like dispersion, you have to build in with the physics of the moving parts. You can't fiddle dispersion with DSP, as far as I know.
It depends on what particular kind of loudspeaker you're talking about, but on a two-way loudspeaker with a waveguide, you are correct. You can't fix that. It's one of the things that I've always said is if you don't have your directivity right, you can't fix it with EQ. You can get it right on axis, but you can't get it right anywhere else in the room. So if you have discontinuities in your directivity index, it's a bad thing. I don't know of any way of making that good enough.
So when it came to your first speakers, I think that was the Lone Pine range. How did you make that meet the price point? Because they were very, very affordable, and yet I thought they performed really well. I did a review on them, and I thought these are good speakers for this kind of price.
Well, in Lone Pine, I think you find really the core of our philosophy is that if we spend enough time doing the math, doing the research, and I can talk about every piece of that system, At the time, there was a very affordable DSP/amplifier that would meet the power requirements with an acceptable level of distortion. We optimized, as an example, waveguide doesn't cost anything, but it allows you to get your directivity right. The woofer was designed specifically to use every bit of power that the amplifier could provide, so you're not wasting any money from the amplifier in this. Everything that we could do to optimize the system, so as an example, everything comes to its limit at the same time. And you have good directivity, you have relatively low distortion, but balanced distortion. We even got to the point where we decided to use, rather than a pretty color litho box, we used a single color plain paper box to save the money that we put into the woofer to make the motor the size we needed to lower distortion by 6 dB. Using a 2-layer voice coil instead of a 4-layer voice coil. We're not using esoteric things like copper caps or other distortion reducing things that you would see in higher end drivers, but what we're getting for a standard quote unquote design is highly optimized. So getting that to that price point, that's kind of where we focus.
And I guess you've done some work on the box. I mean, it looks like a plain box, but you've done a bit of shaping on the port to try and reduce the turbulence in there and the noise. I mean, did you use computer modeling to figure out that shape first, or did you just get in there and build it?
No, we used actually with a startup company, we used an open source computational fluid dynamics program and did, I want to say, hundreds of simulations, command line. A little bit of post-traumatic stress there to arrive at the geometry and optimize the geometry, because on this product you have a front-facing port, and any amount of turbulence or noise you're going to hear. There's port geometries in the intellectual property space, and being able to optimize and get to something that didn't cause us any grief and yet delivered a low noise port, it was a challenge, and it was fun in retrospect. A lot of experience in doing design of experiment and command line FEA.
Yeah, and I guess some of that expertise is now carried forward into this new 3-way monitor, which I've yet to hear.
It is.
So what was the philosophy behind that? I mean, it was kind of a bold move going for a dual concentric, because that by design gives you a symmetrical dispersion pattern, whereas some people like to have more of an oval dispersion pattern.
In everything, there's trade-offs, and the trade-offs with having non-concentric drivers is the directivity anomaly at crossover, which you can't avoid. In a 2-way loudspeaker that's non-concentric, you're going to have a directivity anomaly, and what you can do with it, that we did as good as we could with Lone Pine, and it's quite good. But having a point source allows you to have a uniform radiation pattern regardless of the place in the room. It is a circular dispersion pattern, but I would submit that difference is well worth it. And actually, I prefer the directivity of the dual concentric.
Were there any particular design challenges? Because obviously sticking the tweeter in the middle of a woofer isn't a straightforward job, especially when you're designing your own driver.
No, and in fact, if you're not careful, and there are many systems out there where the movement of that cone surrounding the tweeter causes significant intermodulation distortion. And it's simply because it's a tweeter on a waveguide that's moving.
Yeah, that was going to be my next question. I mean, how do you avoid that? Because, I mean, you're in a 3-way, so it's not moving quite so far as it would if you were in a 2-way.
And that's the point.
But it's still moving.
It is, but it's like Doppler distortion on woofers. And when you have a woofer cone that's moving and it's radiating over a range of frequencies, you will have intermodulation distortion as well. And the key is to be able to, I don't want to say thread the needle, but to keep that intermodulation distortion below the threshold of detectability. So by limiting the mid-range cone movement to less than a millimeter, you bring that intermodulation distortion down to where it is less audible than the directivity anomaly that you're getting away from.
Did you have to do anything else with the box? I mean, you want to make the box manufacturable at a lowish cost, but at the same time, it's got to be well damped and it's got to be the correct volume.
The material that we use is fairly well damped by itself, And of course, we're going to qualify the box to make sure that we don't have any egregious cabinet resonances. But it's not the technical challenge that the transducers or the directivity would be. In a product where you're using like a harder material, where those, where the panel resonances can get out of hand, you need to be careful and perhaps use some modeling. But as we were developing this system and measuring it as we're developing, we didn't have the issues that we had to address on it. It works pretty well. The baffles are fairly stiff. The sub-enclosures on the three-way, as an example, were built such that they didn't have a whole lot of resonances. Correct use of damping material. Just general things that we can do at that price point. Of course, a higher price point, you're going to be spending more materials. You're going to be using stiffer materials. You're going to be putting bracing in, as an example.
Yeah, and I guess that gets more serious the larger the box. I mean, if it's a small box, you can make it stiff fairly easily.
And large boxes can be quite fun.
Okay, so is there anything else you'd like to tell me about this new three-way before it arrives?
So a couple of things I'll draw to your attention on IN5. Actually, draw your attention to the woofer. Not only does this woofer have to have the things that we've built into the Lone Pine and even the Independence, but this woofer, even at this price point, was optimized to have a very good motor force as a function of distance, simply because the woofer is moving quite a bit. So a little bit of extra work went into that. It's a very high excursion 5-inch driver. And also, I would draw your attention to the work that has been done in the amplifier, where we've achieved, at the same voltage sensitivity, about a 12 dB reduction in idle noise. And that's simply by availing ourselves of the latest in the technology of the DSP and amplifiers.
So are you using discrete amplifiers, or have you gone for a one-chip solution?
This is a one-chip solution, but it was selected simply because the signal-to-noise ratio and the distortion, that was quite significant compared to technology that was available even just a few years ago.
So I guess the next thing to ask is where next, because I don't know how far you want to go up the ladder, as it were, until you start to meet the higher end speakers, or whether you're going to concentrate on the home studio guys where the market is wider.
Yeah, we've got a lot in the works, and it seems like more and more every day. We are definitely going to build out the entire studio monitor line, if that answers your question without giving too much away. So there will be... if you look at the Owens Valley, where Lone Pine and Independence are located, you'll notice there are several towns that are even north of those. So that might give you a hint as to where we're going. Based on customer feedback, based on our own experiences with the loudspeakers, we really like three-way studio monitors, eliminating a lot of the problems and a lot of the compromises that have to be made with a two-way monitor, with directivity anomalies, with having, just two drivers to do all that work. That's really nice. And so we are looking at something a little bit more high-end that would use some of the lessons that we've learned developing the IN series as we move up. There's also a lot of feedback that we've gotten from customers about their specific use cases. I really like the LP6. I wish it did this. And you'll see that in the IN5. I really like the LP6. I wish that the self-noise was lower. All right, well, here is our next wave of speakers, and the self-noise is substantially lower. I really like the IN8. I wish it were smaller. Okay, well, here you go. I am working very close to my loudspeakers, and I am mixing completely in the box. I wish there were a solution for me that used less hardware, that used less space on my desk, and you'll see some things coming out from us in the next year or two that help to address some of those problems in unique ways. There's obviously, we could always make a smaller speaker. I think we've managed to make a smaller speaker that doesn't make the trade-offs that smaller speakers traditionally do.
At one time, there was a fashion for small satellite speakers and a sub, which addresses some of those space concerns. wonder what you thought about that, because while such a system has its downfalls, in a room that isn't optimally treated, as many home studios are, at least you can find the right position for the sub to get the most even response in the room. Whereas if everything's in your monitors and the monitors have to go where they have to go, it's not always the best place for the room.
Yeah, that's a true statement. And I can't give too much away, but there is a really good place to put a sub with a pair of satellite speakers. And we are trying to make the best possible use of that in the product that will be coming out later this year.
And next year I can ask you about PA systems and possibly other things, but at the moment it's studio monitors all down the line.
Yeah, turtles all the way down.
Thanks very much for your time.
Paul, thank you so much. Really appreciate it.
Thank you for listening, and be sure to check out the show notes page for this episode, where you'll find further information along with web links and details of all the other episodes. And just before you go, let me point you to the soundonsound.com/podcast website page, where you can explore what's playing on our other channels.